Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on route import and control. Let's start our part 10.
Alright, so let's examine case number 1. So the following figure show part of network topology of company B. Alright, company B has the following network requirements. So altogether we have 3 requirements here. Let's look into the first requirement. Deploy router 3, router 4 and router 5 in OSPF area 0. So we are going to configure area 0 here and import 10.0x0. So we are going to import this into the OSPF. This one is easy. So let's start with our lab first. So let's jump into the routers now. So here I have a 3, 4 and 5. It's supposed to be running OSPF, and here I have the 10 network. Okay, so I have a 10 network here, and I have a 10.0.10 network, 10.0.20 network, and 10.0.30 network. Okay, so first we are going to configure OSPF. So let's start from router 3, OSPF 1. Alright, so let me give them a router ID. Let's say I'm going to give them a quad 3. So question asks for area 0. So this network is network 35.1.1.0.0.0.255. Alright, that's it. So let me try to ping to 35.1.1.5. You can see that it's pingable. I'll go to router 4. Alright, router 4, OSPF 1, router ID, I'm going to make it as 4, area 0, network, this is 45.1.1.0, and finally I'm going to do on router 5, OSPF 1, router ID will be 5555, area 0. First is our network 35.1.1.0.0.0.255. Second network will be 45.1.1.0.0.0.255. As you can see that the network has been converged, and we have the neighbor adjacency fully formed. So let's do a display OSPF peer brief, and okay, so I have my router 3 and router 4 are fully formed. Okay, so this one we just wait for a while. Number 4 is still in two-way. Okay, so once this is done, we are going to import the route. Okay, so just wait for a while for it to form. Okay, so it's formed already. So let's do a brief here so you can see that it's full. Alright, now let's just go into the router 5, and here I have my interface that is running on 10 network. This one is a 10.0 network. Okay, so I do a display to show you that is on my interface G002, and I have 4 different IP inside here. Now I'm going to import this directed interface into my OSPF, and for me to do that I'm going to use a route policy, because only those that's matching 10.0x, alright, that is requested by the question, will allow to be imported. So I'm going to configure the IP prefix first. I'm going to give it a name called 10 index 10 permit 10.0.0.16 greater equal 24 less equal 24. There's a subnet mask of 24. Alright, so I have the prefix list already configured earlier on. Display IP prefix, there you have it. Next I'm going to configure the route policy. So I've configured the route policy. I call it as direct permit node 10. Okay, which I also configured earlier on before I do the recording. Okay, there you go. So I'm going to do a matching IP prefix, which is 10. Right, so next I'm going to show you policy. That's my policy. I'm matching the prefix of a 10, and inside my OSPF I'm going to import the route direct based on my route policy called direct. Okay, So now I go to the OSPF. I go to the display OSPF LSDB. Okay, so you can see that I have imported my network into the OSPF. Let's check on router 3 to see whether I have the route or not. Display OSPF LSDB. Sure, I have. Okay, so these are the route as type 5 in my router 3 and my routing table, and sure enough I have all the route here, 1 2 3 and 4. Okay, so same go for my router 4 here. Okay, let me clear up some things here. Alright, so these are my OSPF route. So that will be on my first requirement. Alright, so let's look into the second requirement here. The second requirement is to summary 10.0x0/24 into 10.0.0.0/16 on R5. So we are going to summarize in R5 because just now when we did our lab, we actually advertised in detail route. And advertise default route on R3 and R4. So in R3 and R4, we are going to use a default route to advertise. So let's look into how we can configure this. Okay, so let's go back to router number 5. So in router number 5, alright, so this is my configuration on router 5. I'm going to configure the summary address. So let me go back to OSPF 1 and this is the ASBR. So I'm going to configure the summary address. The question asks us to use a /16, so that will be 255.255.0.0. Okay, and I will go to router 3 and double check. Okay, so sure enough that I have the /16 here as well as the router 4. Okay, that's correct. Now further on that, the question also requires us to do a router 3 and router 4 to generate a default route. Okay, that is a simple one. Default route. There's a dash here, advertise. I'm going to do an always advertise. I go to router 4, I do the same thing. Default route advertise always. Okay, so I have advertised my default route, display OSPF LSDB. Okay, so you can see that I have the default route advertised. Now I'm going to do a testing here. See if let's say I can do a ping to 10.0.0.1. Okay, so you have no problem. Alright, so but if I'm going to ping, or in this case, let me do a trace 10.0.0.1, you should go direct. But if I'm going to trace to some IP address that is not available and see what will happen. And do you expect this thing happen, which is a looping? You notice that it's actually looping between router 4, router 3, okay, and router 4 and router 3. Okay, so this is a 4.5 and 3.5. Okay, now the reason why it's actually looping is because that when I try to do a trace that is not available, what really happened here is, let me show you the routing table. Okay, so you can see that if let's say I have the route that is available, all right, in the detail route, it will go to 16. Okay, so assuming that the 10.0.0.1 is a working route, it will send to the router 5. But if I'm going to trace to 10.0.4.1, just now as I show you here, this is not a valid IP. So again, it will actually forward to router 5. Now that should be no problem. But the problem is if I go back into router 5, display IP route, alright, as you can see from here, I have a default route. Okay, so when R4 ping to an unknown IP address, it will send to R5. R5 check that, hey, this is not in my interface. All right, this is unknown route. So I'm going to forward between router 3 and router 4. So this is where the looping start happening. That actually leads us to the next one here, how to prevent the loop. So as you can see that the requirement for number 3 is to do a route looping prevention. Okay, so let's jump back into our network, all right, and see how we can do that. Okay, so in my router 3 or the router 4 just now, as you can see that just now we have a loop, and for us to stop this loop, it's very simple. Anything that is not known, is unknown, we are going to put them into the black hole. And how to do that is in router 5. Alright, because the problem happened in router 5 because of this default route that you created in router 3 and router 4. Okay, so this is how you do it. I'm going to create a IP route static 10.0.0.0, alright, 255.255.0.0. I'm going to send it to now 0. Okay, alright, let me do a display IP route. As you can see from here, it's actually go to now 0. So I'm going to redo this one more time and see what happened. If I'm going to trace to an unknown IP address, it will straight away go into the black hole. Okay, so now you have solved the routing loop. Okay, so that is on the case 1 based on the 3 requirements.
Thanks for watching. Please do not forget to subscribe to our channel.